Okay, in this video, I want to start talking about how we can multiply rational expressions and how we can divide rational expressions. So before we do that, let's remember how we can multiply fractions. So if you have any number a or b, c, d, as long as b and d aren't 0, if you're going to multiply these fractions, you just multiply the numerators, so a times c, and then b times d. At the end, you want to simplify, but if they're all different, this would be the most general result we could get. But you multiply the numerators, multiply the denominators. If you're dividing fractions, then you can flip the second fraction upside down and then multiply them. So this would be equivalent to, this is equivalent to multiplying a times d, b times c. Okay, so you can flip the second one upside down and then multiply. And we'll need those results in just a second. Okay, if you need help with fractions, go back in previous videos and look at our fractions, and you can get some help with that. So for the first example, we have this fraction here, this rational expression that we're going to multiply by this rational expression. Since this is a specific question, I want to simplify the best I possibly can before I start multiplying. And so that's what I'm going to do now. I notice that the numerator is the difference of squares, so I can say q plus u, q minus u for just that numerator right there, q minus u, q minus u, and that's times 1 over, and I'm going to put parentheses just so it's clear. What can I simplify? It looks like I can simplify, just completely reduce out q minus u right there. I have a q plus u and a q plus u, and so what am I left with? Just this 1 here, and then q minus u. And so that would be my final answer. Okay, so for that one, we simplified it. We kind of just did our reduction, and that was it. That's all we needed to do. All right, let's look at the next example. In this example, we have rational expression times a rational expression. Again, I'm going to simplify before I start to multiplying things. So what can we do with this numerator here? We have y squared minus 14y plus 49. How could we factor this? Well, y squared is a perfect square and 49 is a perfect square. So I believe that this would be y minus 7 quantity squared. Let's check our cross terms. 2 times y is 2y times negative 7, which would be negative 14y, and that's exactly what we need it to be. Okay, I think I figured out the numerator. What about the denominator? We have y squared minus 13y plus 42. This is a leading coefficient of 1, so we have to find factors of 42, which add to 13. Well, what could that be? 42 divided by 3, no. 42 divided by 2, no. Divided by 6, 6 and 7 would work. So 6 and 7 is going to work. We need them both to be negative, so they'll multiply to a positive number and add to a negative number. So I can factor this as y minus 7, y minus, not 3, but 6. Okay. Now, what about this term? 4, well, that's just a constant, so that's going to stay the same. And then y squared minus 49, difference of squares. So we have y plus 7, y minus 7. Okay, what can I cancel out? Y minus 7 squared over y minus 7, so that will reduce with the fraction. Looks like I have a y minus 7 over here, so I can cancel it with those. Y minus 6, not much to be done. Y plus 7, not much to be done. So that's our final answer. 4 over y minus 6, y plus 7. Okay, that's it. Now, for this one, we have, it's kind of confusing, we have a rational expression here divided by a rational expression here. So how are we going to do this? Well, that's kind of like 1/2 divided by, I don't know, 3/7. And so you can go 1/2 times 7/3. So you can flip the second fraction upside down. And if you do that, then you're able to just multiply. And multiplying is much easier. So let's see what happens. I'm going to go I'm just going to rewrite the top one, top rational expression. Multiply it by x squared minus 4x minus 32. And that's over x to the 8th. So I flipped this one upside down, and now I can multiply, okay? Well, is there anything? It looks like there's already things I can simplify. I'm going to simplify all of the terms to be sure that I get it right. So x to the 5th and x minus 8 is already simplified. Now, this is a leading coefficient of 1. So I need the factors of negative 32, which add to 4. Is that going to be, well, 32, we have 8 to choose from. So 8 and 4 might work. 8 and 4, they need to multiply to negative number and add to a negative number. So negative 8 times 4 is negative 32. And if you add these together, you get negative 4. So that works. So I have x minus 8, x plus 4, and that's still over x to the 8th. Okay, what can I simplify? X minus 8 goes away. I have x to the 5th over x to the 8th. So this goes away, and then this will turn into a 3, and I'm left with x plus 4. So I think final answer would be x plus 4 over x cubed. That'd be the final answer. Again, we can't reduce these x's because these are separated by addition. So that'd be the final answer. Let's look at another example. 48 over x times 4xt over x to the 4th divided by 16x to the 4th over x to the 5th. Okay, there's a lot of steps we can do, but let's do PEMDAS. We're doing the division. Let's just flip this upside down, and then we can just worry about multiplying everything. I think that would really be the easiest for this problem. So I'm going to rewrite that. So I flip this upside down so I can multiply. Okay, now what do we want to do? I can start simplifying things. So I can say, oh, well, there's an x, so that's gone. Here you have x to the 4th, x to the 5th, so you can just cancel that. So now that's a 1. You have 48 over 16 there. So 48 over 16, I think, is 3. Yeah. So this 48 will turn into a 3. 16 goes away. I still have a 4 here. I have a t here. I can't reduce it with anything. I have an x to the 4th. And I already reduced all my x to the 4th. So I think we're left with 3 times 4 times t times... Oh, we do have 1x here. So I should have canceled that. And we have x to the 4th. So I have to do one more step. I can cancel this. That becomes a 3. So final answer would be 12, because 3 times 4 is 12, t over x cubed. And that's the final answer there. Okay. You can skip as many steps as you want, but I think that should be the final answer. All right, again, we have a rational expression over rational expression. So if you flip the second one upside down, then you're able to multiply, and multiplying is much easier than dividing, so let's utilize that. All right, now is there anything I can simplify? Looks like I could factor out a 5 here, so I'd be left with x over x minus 9 times 5x minus 9. And look at that. Looks like I can reduce a x minus 9 there. I still have the x, 5, and the 3, so I think that'd be 5x divided by 3. All right, not too bad. Yeah, so this example we need to simplify quite a bit. We have no division here, so we don't have to worry about that. For this numerator, top left numerator, we can factor out a p. So I'm left with p plus 8. And this denominator here, the leftmost denominator, I can factor out a p squared, so p minus 3, right? And we're going to be able to reduce those. What do we have here? 32 and 96. What can I factor out? Greatest common factor. Looks like it's only 3. So I can factor out a 3p minus, and that's going to be times what? 32. You know what? Tell a lie. I can factor out a 32, not a 3. So p minus 3. That looks a lot better. 4 and 32, I can factor out a 4p plus 8. Yep, there it is. Okay, what can we factor? Or what can we reduce? We can certainly reduce p plus 8. There it is. I can reduce p over p squared, so that will reduce to a 1. And p minus 3 can go away. And 32 over 4, well, that's 8. So I just have to remember what do I leave with. So I have an 8 for sure. Everything on the numerators are canceled. I still have a p here. That looks like it to me. Yep, I think that's all we have left. So just 8 over p would be the answer. Okay. All right, in the next video, we're going to go over more examples like this, but this is how you can multiply and divide rational expressions.